Right. So last time we covered the Python basics, actually our notebook number 1. Now we are going to move on to notebook number 2, which is NumPy. So here we're going to work with NumPy library, and we already know what is NumPy, and now let's explore it. And by default, if when you have installed your Python through Anaconda, Python and Pandas and Matplotlib are already installed. You need to only install the Seaboard and the scikit-learn package for the machine learning. And I think in the first video, I showed you how to install those packages or those libraries already. All right, so let's move on to notebook number 2, NumPy. Okay, so here, the rest of the notebooks are going to be a lot shorter than the first one, hopefully, and then I'll try to keep them as short as possible. Because now you're more familiar with the basics of the Python, then we can speed up a little bit. Okay, NumPy. So NumPy is a library, and we're going to talk about NumPy arrays, NumPy indexing and extraction. It's like lists, something like that. And then NumPy operations. Basically, what are the functions in NumPy that we can use? Okay. Before being able to use the functions from NumPy, we have to go ahead and import the package, import the library, right? Let me actually show you something. Now, if I open this contextual help, now, without running this line, if I come down and when I stop here, it said numpy dot something, it doesn't recognize what is this function, right? Well, it does because because I've already imported this numpy on my computer. But if you haven't imported on your computer, it's going to in the contextual hub, you will not see what is this array function. Okay. So let me actually minimize this one. All right, so we say import numpy as np. This is just an arrangement, right? People out there, the coders, developer, everybody use np as a reserved initial for numpy. You can literally call it anything, right? So you can call it your name, right? So for example, I say import numpy as Vedran, and then when I want to call the functions from that package, I would do something like this. I would do Vedran dot and press tab, right? It's going to say, okay, this module that you're calling functions from has basically some instances. If I scroll down, there are things, these are all the functions that I can use out of NumPy package, right? For example, I can do min, max, argmax, whatever, right? So as a convention, we're going to use np for NumPy. And the reason we do that is I could have done something like this, import NumPy, and every time I just type NumPy and then do dot, right? But in order to save some typing, we say import NumPy as np, and from now on, whenever I type np, Python understands that I'm calling that NumPy library, right? Sorry. You would say that, okay, NumPy is not that long, so why should I use np? Yes, but there are some packages that, for example, you say, okay, from scikit-learn, then classification, then model specification, then something else, import is an initial, import it as an initial, right? So again, it's very useful to just to stay with this convention. So for NumPy, we do np, for pandas, we use pd, and etc. All right. Okay, so now let's see what are NumPy arrays. So imagine, let's start with a list. So I have a list of 1, 0, 1, 2, 3. So this is my list. I'm going to transfer this list to a NumPy, right? So I have to say numpy.array. So this is a function which is waiting for a list. So if I pass a list to that function or any object to that function, it's going to give me back an array. So if I run that, so I will say that, okay, it's an array. And it has 0, 1, 2, 3. So you may wonder, okay, so what's the difference between list and an array? So why should I use NumPy array, not list? Okay, there are two reasons that we do things like this. First of all, NumPy array is super fast. So when you're doing matrix calculations or maybe some complicated iterations that your function is going through, NumPy is going to be a lot more efficient than a list. So that's reason number one. And number two, and for that reason, lots of functions that are written in scikit-learn package, in the machine learning packages, they're using NumPy arrays, not list. So we have to be careful that to understand the difference between the two. So sometimes you will get an error. Actually, we are going to see these errors during the semester. I'll try to point them out. And you will see that you're applying a machine learning function to a data set, and it's complaining. The Python is complaining because apparently you applied that, for example, that function to a data frame, not to an array. So we have to change that column of a data frame to an array. Okay. So again, for efficiency, we know that NumPy arrays are a lot more efficient to work with and are faster to work with. So that's the motivation. All right. Now let's say I have a matrix, right? So I have a matrix and it's 1, 2, 3, 4, 5, 6, and I put it in two separate lines, two separate lists. So it's going to be something like this, right? Now I can transfer this matrix to by using NumPy array. And basically it's going to be an array of 2 by 3, right? So I have 2 rows and 3 columns. Actually, I can reshape them. We're going to talk about reshaping a matrix, I think, down this notebook. But for now, let's move on. There are some built-in methods in Python. Sorry, in NumPy library. So what are built-in methods? It means that if you do NumPy dot something, it's going to basically use some built-in functions, right? So do you remember we had a function called range? And let me actually show it to you. So we had something like range, right? I do range 0, 4, it will give me a range of between 0, 4. Guys, remember I have to do a list because I want to see what is inside that range, right? This is a list, right? If I want to make this to an array, I can do something like this. NumPy.array, the entire thing. Now it's an array. So instead of doing something like this, NumPy array, this whole thing, we can use a built-in function, and that built-in function is a range. So array range, right? So if I do a range between 0, 4, it'll give me the same answer. Okay. So one of those built-in useful built-in functions is NumPy array range. So between 0, 4. Again, you can play around with the steps. Give me something between 0 and 10, not including 10 with the steps of 3. So it's going to be 0, 3, 6, 9. And some other built-in function like zeros. If I do NumPy zeros, remember it has a S as well, zeros. And look at the documentation, look at the contextual help. So basically 0, it will return a new array of given shape and type filled with zeros, right? So for example, I said that, okay, give me 5 zeros. And I can give it two arguments, like just give me a 5 by 5 matrix of zeros, right? 5 by 5. Give me ones, give me a 5 by 5 ones, right? Then there's another built-in function, which is lin space. So it says that take the range between 0 and 20. So lin space will include the last one, unlike a range. With the space of 5, right? So it is 0, 5, 10, 15, 20. Then we have I. This is identity matrix, NumPy I, 5. So it is, by default, we know that identity matrix is a squared. So I don't need to pass 5 and 5. If I do a NumPy I, it's a squared matrix. So on the diagonal, we have 1. And off the diagonals, we have zeros, right? Then we have lots of random generators from NumPy package. Okay. And one of them, so let me actually back up a little bit. If I do NumPy, then random, right? And then do that tab. So it's going to, oh, I misspelled it, sorry, random. It's going to show me the available distribution that I can pick from, right? So from our statistics or econometrics course, we know that we have different types of distributions. And for example, when we were calculating the PDF, CDF, and things like that, so we can use in NumPy package, NumPy random module, and from that random module, use some functions, right? So we have beta distribution, binomial, chi-square, exponential, gamma, and you name it, right? Of course, log normal, and etc. So where's our friend normal distribution is here. And you see there are lots of things that you can pick from. We can set the seed and etc. Okay. So if I do rand, so this is going to look at the contextual help. It's going to give you random values in a given shape, create an array of given shape, and populate it with random samples from a uniform distribution, right? So it says that give me a random let's say 5 random numbers from a uniform distribution. What is uniform distribution? Distribution between 0 and 1, right? So if I do that, you see okay, sorry, rand 5, give me 4 numbers. It will randomly give me 4 numbers from a uniform distribution between 0 and 1, right? So if I run it multiple times, I'm running this line multiple times, right? I get different numbers, because we know that there is this random generator is going to sort from one seed every time, random seed every time, and it's going to generate a random number, right? These are very useful later on, that if we need to, for example, generate some random numbers for any exercise, for bootstrapping, for Monte Carlo simulation, and things like that. All right. You can, so by default, it's going to give me an array of 1 by, basically, it's a vector. Now, if I pass 5 by 5, it's going to be a matrix of 5 by 5s. Again, if I run it multiple times, every time I'll get a different number. All right. And yeah. For example, we can select numbers from the normal distribution, so standard normal distribution. So the function is rand n. So this is a standard normal distribution, as you can see, standard normal distribution. If you need 5 of them, or if you need a matrix of 5 by 5, and etc. Right. So again, another example is rand integer between a and b. So it says give me a random number between 1 and 5, and it's an integer number, right? It include 1, exclude 5, right? So you have to read the documentation and see what the author of the package or library decided to do. But usually convention is that when we do range and things like that, it starts from the first number and go to the second number, not including the second number. But there are exceptions as well, as you saw up there in one of the functions, I think a link space function, right? It included 20 as well. Anyways, okay, so random integer, let's say, so this time it was 2. Let's do random integer. We can say, okay, give me 20 of them. So give me 20 of them, random numbers between 1 and 5, integers, not including 5. Okay, now we're going to see what is seed, S-E-E-D, right? It is used to fix the random state, right? So I think in our machine learning exercise, we're going to set the seeds most of the time. Because, for example, if you want to see exactly the numbers that I have in my notebook, you want to see it on your local computer, you have to use the exact seed number that I'm using on my computer, okay? Otherwise, each time that the machine learning model is being run behind the scene, it's going to use a random number, and your numbers are going to be different. This doesn't mean that, okay, your answer is going to be completely different than me. But at the same time, it means that if you're using a different seed number, your answer is going to be different. So for example, I give you a homework. I say, okay, what is the accuracy? There's no exact number. Maybe on my computer, the accuracy is 89. On your computer is 89.1. On someone else, 88.7. But it's not going to be way off, okay, depending on that seed number. So what does setting seed do for us? So I have to say numpy random seed equal to 100. Now, if I do not run this, well, let me comment this out. If I simply run numpy random, give me 5 numbers from normal distribution, right? Every time this number is changing. Now, are you following, right? Every time this number is changing. Now, if I set the seed to any random number, right? It can be anything. It can be 100. It can be something as stupid as this, right? Any number. I'm just randomly typing numbers in, right? So let's say 100. Now, if I run it once, the number is going to be -1. So for example, the first random number is -1.74, the second 1.34, and etc. If I run this cell multiple times, I'll get the same answer. Look at that. 1, 2, 3, 4, 5. See, I get the same answer. So that's why it's going to set the seed, and the random generator is going to always start from that specific seed and generate and pick numbers from a normal distribution in this example, right? So again, this is something important. We have the same story here. Again, the numbers are not going to change. And now let's talk about some array methods. So what are the methods? Imagine I have an array, and it's a range from 1 to 9, not including 10. So this is my array. So the first method that we use is called reshape, right? So guys, if you hear me using method and the function interchangeably, that's just fine. They're doing basically the same thing, but methods are off of an object, function, or no, we have a function and we have to put something inside that function. That's the difference. But basically, you're taking an input, giving an output. That's it. OK, so I'm going to say that, you see, this is my array, right? The array is 1 through 9. I want to reshape it by 3 by 3. I want to literally make it a matrix. Look at that. So I have a matrix of 3 by 3. Then I can look at the shape of it. It says that the shape is 3 by 3. I can make a new array. And basically, oh, sorry, we already have this new array. I can look at the type of it. So I do dtype. The type is integer. And then I can use this type function as well. So this is method, this is function. Basically, they're doing the same job. They tell you this is a Numpy array. Then, do you remember in the list we had append function, append method? For Numpy array, we also have append method. It does exactly the same job. I'm going to say that append adds something to this my existing array, which is 1 through 9. What do you want to add? Numbers 100 and minus 100. Okay, let's do that. So it's going to do this job and adding 100 and minus 100 to the end of it, right? Now, out of this my array, I want to see what is the maximum. What is the maximum? 100. What is the minimum? Or what is the argmax? So this is what is the maximum from these numbers, 100. Argmax is what is the location of that maximum number. So it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the answer is going to be 9. This is important because when you're doing optimization, so this is not a topic for the course, but in one class I will talk about optimization, gradient descent and descent, algorithm, things like that. Then I may provide a notebook. Again, I don't need you to know it, but if you want to know what's happening behind the scene, you should realize that. So for example, what is max? What is argmax function doing? The same story for mean and argmin. So what is the mean? Minus 100. What is the argument? The index of that minimum number? The last one, 10th. All right. Indexing and extraction, it's very, very similar to the list extraction. So nothing new here. So if you want to extract the 10th element, you have to use the index 9, right? Let me use a simpler example. So if I want to extract, let's say, this element, what should I put here? 1. There you go, right? Because indexes start from 0, right? So that's index 2. That's index 1 and the elements 2. If I want to extract the last one, so what do I do? Minus 1. So what do I get? Minus 100. Okay. So again, if you practice it enough, it becomes natural. Then you can extract a range. So let's say give me index from 6 to 9. What does it mean? Element 7 to element 10. So it will be 7. This is my element 0, 1, 2, 3, 4, 5, 6. Okay. 7, 8, 9. So if I do that, it goes from 7 to 9, right? Then with Numpy arrays, you can broadcast a single value across a larger set of values. OK, so this is not possible using a list. So here's another difference between a list and Numpy. Guys, these are technical things, but I think you should at least know what's going on, because sometimes you will get an error and it's really hard to fix that error. The reason is that library, the function in that library is designed to work with an array, not a list. This is one reason why, because arrays are more efficient and more flexible. Let's look at the array. So if I look at the first 5 elements in my array, so what do I have? Oh, sorry. I say, OK, replace the first 5 elements in my array with a numbered 100, right? You remember, before doing that, this was my array, 1, 2, 3, 4, 5, and up to minus 100. Now I said, OK, replace these 5, the first 5 ones, with 100. I can do it in a very simple way like this. Pass the range and set what do you want to do with that, right? Okay, I want to replace them with 100, 100, 100, 100, 100, 100, and then do not touch the rest of it. I cannot do something like this with a list. So imagine I have a list. I call it my list. Go from 1 to 9. And the first 5 elements are this. Now, if I go ahead and say that, OK, change the first 3 elements from 0 to 2 to 100, I'll get an error. It says that can only assign an iterable, right? So list is not an. So it means that if you want to change these 3, the first 3 elements, you have to pass 3 elements to a list. Now I can. Do you see the difference? If it was a range, I didn't need to pass 5 of these hundreds. But if it is a lease, I have to do, let's say in this example, 3 of them. So it's a big deal because sometimes, your column in a data frame has millions of records and you want to replace, let's say, 10,000 of them by a specific number. And you better work with a Numpy array, right? Does that make sense? So that's another reason that why we should, again, why the authors of the packages work with Numpy array, not list necessarily. All right. Now let's see. Let's make a matrix very quickly. We're going to say that basically we want to extract things from matrix. This is not something that we use for the course, but regardless, I'm gonna show it show it to you what is extracting numbers from matrix, because when it comes to data frame, the argument is going to be very the same. Let's say I have a matrix. Its matrix goes from. Let me actually show to you what I'm doing. If I do Numpy Range 0 to 6, so what is the answer? 0 to 5, right? So I can make it even 1 to 7. Right? It goes from 1 to 6, right? Not including 7. Right now, I can say continue doing some operations to this object of mine, right? So what do you want to do with that? I said, okay, reshape it. Reshape by a matrix of 2 by 3, right? I can do all these things in one line, right? So I can say, okay, do it 3 by 2, whatever. You see, it's a matrix of 3 by 2. And then I can say, off of that, give me something, right? So you can, in Python, it's really cool. You can basically do multiple functions to an object. So in R, we use a pipe operator. In Python, we just use a simple dot, which is very, very useful in Python and practical. Okay, so let's say this is my matrix. And imagine I want to extract the first row. If I want to extract the first row, this is the matrix logic. So if you do 2 brackets, the first bracket is row, the second bracket is column, or you can make it a mix of them. Open, close bracket, and there's a comma in between, right? We have rows and columns, right? So if I do my matrix 0, it will give me the first row, right? Because again, remember guys, index 0 is 1, so the first row. If I do it 1, it's going to give me the second row. Okay, not surprisingly. Okay. Now let's extract the first column. I'm going to say that if you want to extract the first column, say, you see, I'm using this version. Sorry, this version. So I have a comma, and then on the left, I'm expected to pass the rows, right? So if I use column like this, it says that, okay, give me all the rows and the first column. Okay, all the rows and the first column, right? So what is this? All the rows, first column, so 0, 3. And I could have done, there is, for example, and here's an exercise for you. You can check that this is first row, second column. Is it the same as if I do it this way, first row, second column? The answer is true. Basically, you get the same answer. And here is the maybe more comprehensive version of that. Remember, this is my matrix. And imagine I want to pick the first 2 rows. So I go from 0 to 1, basically 0, 1, not including 2. So first 2 rows and columns starting from column 2 onward, right? Again, guys, I want you to get used to indexing in Python language. So the index starts from 1 number below whatever you're thinking. If you're thinking of column number 2, index is 1. Okay, so look at that. Column number 2, 1, and both of the rows, 1, 4, 2, 5. So if I do it, 1, 2, 3, 5. Again, you don't need to memorize anything. If you just simply do Numpy array indexing, I personally don't memorize it because it's not worth doing that. So if you just Google Numpy array indexing and then go to Google Images, you see there are cool things that you can do. For example, if you want to grab these green ones, only the green ones, right? Green cells. So how should I do that? You have to do, this is your Numpy array, and then 2 semicolon, sorry, 2 column, 2 comma, column, 2, right? There are different ways that you can extract, but we don't need to go beyond something like this for the course. Something like this, right? Just remember, the first element is row, the second element is column. All right, let's move on. We can extract with conditional selection, right? So what does that mean? Imagine this is my array, and I want to extract only the arrays that the numbers are greater than 50. This cannot be easier than that. I say my array greater than 50. What's the output of this? True, 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 true. Makes sense, right? 100 is greater than 50, so true, 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 true. False, 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 true, false, right? Now, this is an object, right? This object has some true and false. If I pass this object, this is my condition, to the array itself, to my array. So let me actually do it in 2 steps. I call it my condition, and then condition. So this is my condition. Now, if I do it like this, do you remember that if you only pass one bracket, it's going to go over the rows? So basically, it's going over the rows that this condition is true. So if it is true, it's going to return that number for me, right? So if I do that, I'll get 100, 100. So it only returns the numbers that are greater than 50, right? So usually, we don't do it in 2 steps. So we just say that, OK, this is your condition, and then we put the condition here. OK, that's basically the same. Again, guys, this is another advantage of using arrays instead of lists. You cannot simply, this is apply, not apply, simply apply the comparison operator. You have to use filter or map function. You remember we use the filter function, but as a Numpy array, it's easier. We don't need to do that, right? Look at that. So if I want to use the filter function, I could have done something like this: list filter lambda, remember that function that we have to pass? If x is greater than 50, then pass my array. I'll get exactly the same answer, but look at that. How convenient is Numpy array? It's very simple. So I hope that you realize why the developers are working with Numpy arrays, and what I mean when I say that it's more efficient than a list. Okay, for all these things. But these are something that we should know, because sometimes it's easier to work with lists of a data frame and then work with things like this. So there are 2 ways to do that in Numpy array: it's an easy way, hard way. But I highly encourage you to learn the hard way as well, because sometimes we need to apply these things to a list, not a Numpy array. All right, then imagine this is my matrix. You can apply the conditioning factors to the matrix. Let's look at the elements that are greater than 1, right? So again, exactly the same thing. It's going to say 2, 3, 4, 5. But however, remember, the shape is going to be changed. So the shape is not reserved. So here, this is a 2 by 3 matrix, but now we have a 1 by 4 matrix. All right. Operations. So let's define a range, Numpy array. So it's a range between 0 and 4. If I simply add them, so it's going to do something like this. I can make them to the power of each other. I can divide. So for divide, when you see this, these are warnings in this purplish color that you see below this, below your cell. These are warnings. We can go ahead and run a simple line of code at the beginning of the notebook to make sure that these warnings are not there. But I do not encourage you to do that, because warnings are good. You should like the warnings because it tells you what's going on, right? So do not hide your warnings in your data in your Jupyter notebooks. So I personally don't do that. If you want, you can, if you think that it's going to be more cleaner. But I don't want you to do that, at least for the course, because you should see what are the warning. These are not errors, so it means that it's going to be able to run the code. But remember, something is going on. So here, for example, what's going on? Remember, my array is 0, 1, 2, 3. If I say 0 divided by 0, I'll get a not available number, NaN, right? So it's basically telling me that there's a NaN there. If I do 1 divided by array, so 1 divided by 0 is infinity, I'll get an infinity. This is a warning, right? And then the rest of it. Then we can call lots of functions out of NumPy. So for example, if you want to calculate the square root, so if square root of an array is square root of 0, 0, 1, 1, 2, 1.4, and etc. We can do e to the power, or exp, e to the power of 0, 1, e to the power of 1, 2.7, and etc. We can do natural log. If I do np log, by default, it's natural log, remember. And so this is a natural log. And then let's do some summary statistics on array. So for example, I can say, remember this is my array. I can say, give me the sum. Okay, 10. Simply adding this thing. Give me the average. Give me the variance. Give me the standard deviation. Give me the mode, and etc. Okay, access logic. So this part actually is going to be a little confusing, and because we don't, I don't want you to confuse this one with the one which we have in the pandas data frame. So I'm going to skip this part. But feel free to read through it. It's not that complicated, but we're going to use the other version in a pandas data frame, and the logic is completely reversed. So in order to reduce some kind of confusion, I'm going to skip that. But just, again, for your own sake, you can read through the rest of it. It's only 10 lines, I guess. All right, so see you. That was NumPy library. And in the next video, we're going to talk about pandas. So see you in the next one.